Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 14th March 2023. The problem statement for today is maximum number of coins. This problem is based on dynamic programming and matrix, and this has been asked in Make My Trip interview. Let's now open this problem. First, we will try to understand the given statement clearly. Here it is said, we have been given n balloons, each with a number of coins associated with it. On bursting a balloon I, the number of coins gained is equal to a of I minus 1 into a of I into a of I plus 1. Also, balloons I minus 1 and I plus 1 becomes adjacent. Find the maximum possible profit earned after bursting all the balloons. Assume an extra one at each boundary. So here in this question it has been asked that we will be given n number of balloons and some of the coins is associated with each balloon. So on bursting any balloon we get some of the coins that will be a of I minus 1 into a of I plus 1. So these many coins will get for bursting one balloon. Also, and if you are bursting the balloon I, then after that particular balloon is burst, then the balloon at position I minus 1 and I plus 1 that will become adjacent. So we have to find the maximum possible profit earned after bursting all the balloons. Okay, and just for the boundary conditions, so where only one will be left, so here it is said that assume that there is one extra one at each boundary, because multiplying one with any number will does not impact that number, so that's why this one has been considered. Let's try to understand through the given example. Here it is said that two number of balloons are there, and price array here, the cost associated with this one, the number of coins is 5 and 10. So here two balloons are there, and this is the array here with A, and this has been given as an input. So on bursting 5 we get the number of coins as 1 into 5 into 10, that is 50. Then then bursting 10, that means the second balloon, we get 1 into 10 into 1, because since we have already bursted 5, so this 5 has been removed from the array. So now, and since in the question it has been asked that assume there is one extra one at the boundary, so it will be like 1 5 10 1. So after 5 has been removed, that means 5 has been bursted, so so now the boundary 1 at the starting, that will become adjacent to 10. So that's why on bursting 10 we get coins as 1 into 10 into 1, that is 60. So here, so this is the maximum profit that we can obtain. Looking at the example number 2, where it is said the number of balloons is 4 and the number of coins associated with this is given in array A. So here it is said the output is 167. So here, here it is said that initially when we are bursting 1 here, so that time we will get the number of coins as a of I minus 1, that is 1 before that, a of I and a of I plus 1. So 3 into 1 into 5, that is this one. So since 1 has been bursted, 1 is removed from this array. So now 3 and 5 became adjacent to each other. So now if you burst 5, then the number of coins we get is 3 into 5 into 8. So after that 5 has been bursted, then this is left with 3 and 8. And 1 is extra there on both sides. So once we are bursting 3, then we get 1 into 3 into 1, because again for the same reason 1 and 8 become adjacent to each other after 3 is bursted here. So 1 and 8 become adjacent to each other, and 1 was again there at the end. So when we add all of these, so we get 167. So I hope both the examples are clear. So here the approach we will use to solve this problem will be the dynamic programming approach. The idea is to consider all possible combinations of balloons and calculate the maximum number of coins that can be obtained by bursting them one by one. To avoid recomputation of the same subproblem, we store the result in a subproblem in the 2D array matrix. Okay, so just to save time, I have prepared the solution. I'll explain it line by line with the example as well. Let me just try moving it a bit left. Yeah, now it's fine. So here what we are doing, if you look at this complete programming in this one, so what we are doing, we are adding 1 at the beginning and end of the array and converting it to an array list. Then initializing a 2D matrix, that is DP, with a size of n into n, where n is the length of the array list. Then we are iterating over the length of the subarrays using L, that will be from 3 to n, starting index I from 0 to n minus L. This one first we are starting the length of the subarray from that is L from 3 to n, and then we are starting index I from 0 to n minus L. Then we calculate the ending index that is j using I and L, that is I plus L minus 1. Then for each subarray, iterate over index k from I plus 1 to j minus 1. So actually if you look at this one, so we are defining the boundary here, we using I and j, and we are using another variable that is k for iterating from I to j, and during those iteration, it will try to find all the possible combinations through which we can get the maximum profit. I hope this is clear. So the way I said, for each subarray we are iterating over index k from I plus 1 to j minus 1. We calculate the maximum number of coins that can be obtained by bursting the balloons in the subarray one by one. Then we are storing the maximum number of coins in the DP array matrix for the subarray, that is from I to j, and the final answer will be stored in DP of 0 of n minus 1. So how this will be stored? So that I will be explaining it now. So if we take this example 3158, then I have created that final resultant DP matrix here. So what we are doing here, first we are appending 1 at the beginning and 1 at the end. Okay, so this will be the resultant DP array. So here we can see the maximum value is at I is equal to 0 and j is equal to n minus 1. So that is the one we are returning finally from here. But if we try to understand it, that what exactly is done here, so we are so since we are starting from where it is, yeah, since we are starting from this length is equal to L is equal to 3, because we have to consider the 3 in one window or one array size, and we are starting from I and j, and what is j here? J is, that means the ending array is the combination that is made from I and L. So that's why it is getting started from in this one. So if you can see this one, so firstly it will populate 3, 15, 40 and 40. That means this diagonal, it will get populated. This one, if you can just see this one, 3, 15, 40 and 40. So how this is getting populated? See, if you see the product of first 3, initially we are considering that only 3 combinations are there. So this one, so product of first 3 is 3, product of next 3 is 15, product of next 3, that means 1, 5, 8 is 40, and again the product of 5, 8, 1 is 40. So this diagonal is getting printed using those combinations. So in the subsequent step, so in the next iteration, when L will become 4 here, when L will become 4, so that time, sorry, So in the next iteration, when L will become 4, then N will become 4, then I will start from again from 0. Yeah, but this time the index of J will be incremented by 1. So here now it will try to populate this array. Since J index has been incremented by 1, it will populate this one. So how we are getting to 30? So for getting 30, we have to see the combination from the both sides. That means we have already solved one layer before that. So the maximum result which we have got from the sub problems is stored in this diagonal. So we will try to use in that one. So how we are getting to 30? So first we are trying to see out. We are trying to utilize this one left side and this downward side. So we already have these two sub problems solved here. So first we will try to utilize we will add 15 plus 0. Okay, this and this. See, because if you see k is starting from I, it will goes up to j. So j is here fixed only. So j is here. This one, the column number is fixed, but and I is for populating this one, k will be starting from I is equal to I plus 1, and this means k is equal to I plus 1, and then it will go up to j. Okay, so first we are trying to add 0 and 15 to this. We add multiplication of 1, 3 and 5. Initially I is equal to 0 here and j is equal to 3 here. So first we will take 1, 3, 5. Then in the second time we will take 3, 1, 5. That means 1 and 5. These are the boundaries of that one, and k will iterate from 3. That means I plus 1 to j minus 1. So it will take from 1, 3, 1, 3, 5, and second time it will take 1, 1, 5. Okay. So using both these combination, we will see where we are getting the maximum value. So for getting 30, if I try to just write it down, so for getting 30, it will be like 0 plus 15. If you do a dry run of this code, then you will get this one only. Then 1 into 3 into 5. So it will be like 15 plus 15, that is equal to 30. This is one combination. Second combination, we added 0 and 15 here. Second combination was to add 3 and 0 here. So it will be 3 plus 0 to this. What we will add? What will we add? Multiplication of 1, 1 and 5, because previous time we have considered 1 and 5. These are fixed. For k value we consider 3. This time we will consider 1. So it will be 1 into 1 into 5. 1 into 5. So it will give 8. So out of these two, which one is the max? Math not max of these two. So we get max is here, max is 30. So from there only this 30 came. Okay. In the next one, in next iteration of k, where it is I plus 1, it will populate 135. We'll see this example as well, that how we got 135. Sorry for the background noise, some construction work is going on. So how we are getting to 35? So this time we are populating this one. That means where I is equal to 1 and j is equal to 4. That means 1, 4. So for this one we will try to utilize both side value. So here it will be 40. This one 40 plus this 0. So it will be 40 plus 0. Then to this we will add. See here, our I is equal to 1, j is equal to 4. I is equal to 1, j is equal to 4. So here we will use k from starting from I plus 1 to j minus 1. So here the first combination will be I is equal to 1. What is the value at 1? It is 3 into 1 into 8. So what we'll get here? We'll get here 40 plus 24, that is equal to 64. Second combination will be to use this variable, this value plus this 0. See, when we will be calculating 168, then that time these values will be beneficial. We'll be utilizing them. Initially, since it is 0, that's why we are not able to utilize them. So here, what we are doing, so this time we will consider 15 plus 0. Then this time we will take, last time we took k value as 1. Here, this one, starting from 3 to 8, we took this one, this value of k. This time we will take array of k, that will be 5. So 3 into 5 into 8. I hope this is clear. I is still pointing to 3 and j is still pointing to 8. And k is ranging between all the combination in between them. So first we took 3, 1, 5, 8. This time we will take 3, 5, 8. So it will become 15 plus 120, that is equal to 135. So this way we have got 135 here. I hope this is clear. So this way only we will the complete computation of the DP array is done, and at last we will get this maximum value at this 0 of the DP of 0 and n-1. We will simply return that maximum value. I hope this point is clear. Let's try compiling this code. So here we can see we have got our output correct. Let's try submitting this solution. So here we can see even it has covered all the test cases successfully. So talking about the time complexity of the given solution, it is in the order of big O of n cube, where n is the length of the input array list. The outermost loop iterates n minus 2 times, the middle loop iterates n minus l plus 1 times, and the inner loop that iterates to j minus I minus 1 time, that is the kth loop. So the time complexity becomes big O of n minus 2 into n minus 2 into n minus 2, that is in the order of big O of n cube. Talking about the space complexity of this given solution, it is big O of n square, where n is the length of the input array list, and we are using 2D matrix, that is DP, of size n into n to store the result of sub problems. I hope this is very clear, and whatever I explained, that is also very clear to you. If you have any doubt related to the solution or any confusion, you can just comment in this video. So I will be providing the link of this question in the description box. Please do check that. That's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.